Hello everyone and welcome in today's video. Today I'm going to show you how to model the previous question which we solved with hand calculation, which was basically to find the inflection point of this L-shaped frame and where it's positioned, and we needed to do that by using the force method. And we already did that by doing the hand calculations and finding the place where this inflection point. We used force method to determine where this inflection point is located, and according to our hand calculation it was located at 1.47 meters away from support A. And this is the model, so I will show you step by step how to model this one. So first off, let's just create a new model by pressing Ctrl N, and now we need to choose the option which says frame 2D design. And now we're going to start modeling from the scratch. So first off, what we need to do is that we can define the members. And for this case, as we are only interested where the bending moment change, it doesn't matter that much, to be honest, what type of member are we going to choose. So therefore, let's just start by modeling the first member, which was AB, which according to our exercise, if we go back, it's going to be 3 meters, and BC 2.5 meters. So now we are going to go 3 meters from here, and now we hit right click mouse button and we're going to have the member here. And next, let's just model the other member, which is going to be 2.5 meters, as you can see here from the member and coordinates. And now we have our members. So the next step to be done is to define the support reactions. And at point A, we have a fixed support, and how we can do that is that we select the fixed support and we just select the node here. And then we successfully added the fixed support at point A. Next, we would have the roller support, where basically, if we can see here, the roller support does not take any bending moment, as we already know, and it's free to move on X direction according to our exercises we can see here. So everything is okay. We select the roller support, and then we have to select the node, which is going to be node number 3, and then we added the roller support. The next step to be done is to define the load which is acting on member AB, and for that we need to create the first load case by selecting these load types options here. And the load is horizontal. Actually, for this exercise, it does not matter how we can call it, if it's a dead load or some other type of load. For the purpose of exercise, let's just go with a dead load. And now we already added this load case, and what we can do now is that we can define a member load on this member, which is going to be distributed load. Next, we go to the load definition, we go to member load, and then we have this option here, which is a uniform load. And then, as you can see here, we can add this distributed load into direction, which is going to be X and Z directions. For our exercise, the load is on the X direction, therefore with value of 5 kilonewtons, we just press add. Now we select the member to which we're applying this load, which is going to be member number 1. And after that, we hit close. And if we want to see our distributed load to this member 1 in our exercise member AB, we just have to press these two options which says the load symbols and the load value descriptions. And now we have a 5 kilonewtons load added here. And now we have a 5 kilonewton load added to member 1. And as you can see here, the member length is 3 meters and this is 2.5 meters. So everything is correct. And now what is left to do is to run the analysis. And we press this button over here. This is done now. And after we run the analysis, it's important to remember that also while doing the analysis, this takes into account also the self-weight of the members, which for this case is ln30 by 20 by 3. And if we do not want to take into account the dead load, we go to the loads. So now we right click on this gray square, and then we select the option cut, and it will ask you for this one, do you want to continue? Yes. We do not want to include the self-weight, and now we deleted the self-weight. And now if we hit calculate again, and now we want to see the results, and to do that we go to the results, diagram for members. Actually, for the parameters of how they are going to be looking like, I prefer these options here, and I just hit apply. And now let's go to show the bending moment diagram. Yes, so this is going to be the bending moment diagram for this L frame, which we got from the exercise. As we already calculated by hand, this value of bending moment here is 16.63 kilonewton meters, which is correct. And now the exercise was asking us to find the point, the distance where we have the inflection point for this frame. And to do that, we select by right clicking the member 1, So now right click and select member 1, and now left click, and now what we need to do is we need to show the values of these forces for this member, and we go to tables. As we want to show only the values for this member, we just go to this option which says table filter to current selection, which is member 1, and now we go select the forces. And now we hit OK, and the new dialog box is going to pop up where we do have the forces acting on this member number 1. And now if we want to find the point where we have this change of values of from positive to negative bending moment or otherwise, we need to right click on this gray area here, and we need to go to the options table columns. Now we need to go to the division points, and basically we have to choose the option characteristic points, which basically shows all the points where there is some changes in the member. In that case, is going to be the bending moment for us. Now if we hit the button refresh, we're going to see the values. As you can see here, it shows the points to which the bending moment changes from positive to negative, which is x at 1.47 meters, and what we calculated is correct. So thank you very much for your time. This was the video for today. I really hope you enjoyed it. Do not forget to like, subscribe, and if there is any questions, leave your comments down below. Thank you very much for your time. See you on the next video.